Hello and welcome back to another video. So I've been promising you guys to make a video about how we did the customization of the characters in OpenSuspect. So let's take a look what I'm talking about. So here we are at the character customization dialog, and you can see that I can change my character's hair color and hair color of the facial hair and skin color. So let's say I want like a redhead with very light skin tone. I can do that. I can switch around the clothes. Let me just remove these glasses here. So I can switch around the facial features. I can switch around all the different facial hairs. I just did this. Let's take a look at different hair and hairstyles and hats that are available, or different facial expressions. I can also randomize my character, which changes all skin, hair, and facial hair colors and all the other things. So you can see that, well, let's change this hat for something more fitting with these clothes. So you can see that basically all these different elements can be changed, and we can test here how it looks in real life, and we can save it and then it will appear in game. So of course this poses some kind of a challenge for designing all the clothes and all the hairs and the hats and the facial hairs, so everything matches up with everything else, because it's highly customizable. And because this game is a social deduction game, then once after I started the game, well, of course it doesn't make much sense to play this game alone, but anyways, we are still before alpha. It is early in development. So once I'm in game and I change around my character, let's just randomize until I find something nice. So once I got my character changed, that would be an issue, because well, this is a social deduction game, so if I could change my appearance, then that would make it so that the other players wouldn't notice, wouldn't recognize me, so something like that. But once I go back to the lobby, you can see that my character customization have been applied here. So I would like to take a look at the source code and show you how I achieved this kind of customization with our game. Alright, so first of all, we are going to take a look at this player scene. So this is a scene that contains all the nodes that are related to how the player is appearing on the screen, but it also contains a lot of technical things like the collision shapes for interacting with the environment and other things, death handler, item handler. So these are kind of the functional parts of the players while they are running around on the map. And we also have this skeleton in the middle, which is a little, I think, not the best way of naming this node, but this node is coming to this skeleton scene here. And so the skeleton scene contains all the different sprites that are used. So basically there are two categories, or two things that make a sprite separate from the others. One is that if it's separately customizable, then of course it should be a different sprite, because we need to be able to change what kind of image is shown at that sprite. So that has to be a separate sprite. So here, that's why facial hair, face wear, and hat, hair, or mouth, or clothes, these are separate, because these can be separately exchanged in our customization. And we have some that cannot be separately adjusted. So left arm and left leg and pants and right leg and right arm, they are always changed in tandem with the clothes, but these are added here separately because they move separately. So this is of course part of the character design process, that we need to break down like each part to, like, I need to break it down like the pants and the right leg and left leg when I draw the character, and put them in separate images. And so you can see that some of these, especially those are that moving left arm, left leg, pants, right leg, and right arm, these are using this polygon 2D type of node. And some of these that are not moving separately, just following the character itself, it's the clothes, mouth, etc., are just using the regular sprite node. So the advantage of using the polygon node is that I can, where is this? I can go and select edit UV, and you can, yeah, here we are. So I can make a UV map for the hand, and then I can attach these to the bones that I want to. So the bones will be basically helping us with animation. So these will animate the character for us. So this animation player is basically telling the bones to move, and these bones are attached to these polygons. So when the bones are moving, these polygons will be moving and being distorted. These ones here, clothes, mouth, facial hair, face wear, etc., these don't move separately. They just always follow like this basic spine, the movement of this basic spine, so they don't need to be separately mapped polygons. They can be just regular sprites. Alright, so this is how our skeleton is built up, and this is not part directly, so this is like added to our player scene separately because it is easier to use the appearance editor this way, because I can just add the skeleton node to the appearance editor and just scale it up, and it will have all the animations that the player has. So this is a kind of, this makes it a little easier to work with this. And so let's take a look at how the customizations are stored, because once we have all these different nodes, so of course during so in the editor you can see that some of the sprites or all the sprites have been loaded to this. I have a video in which I talk about how the different colors are changed using a shader basically, so that will do the customization of the colors. But we need to be able to change all the sprites and the colors during the game, so at runtime, and for that we have an auto load. So I can go here to the project settings, and you can see that we have an auto load here called Appearance Manager, and this is the one. So this auto load script manages everything related to storing and changing the customization of each character. So it's not just the player character, which is stored in the My Customization dictionary, but actually all the players, because this is a multiplayer game, these customizations will be stored in the customization dictionary. And we have a customization path here, which is basically the save file in the user's dictionary that will contain the persistent storage of the appearance of the player's character in a file. And we will have this sprites there variable that basically tells the game, tells the engine where are these character sprites, the image files for the sprites are stored. We have two dictionaries that define what are the files we are looking for. They are separated by which part of the character they are responsible for. So the clothes that are changed together are in these 6 separate directories, because so when the clothes are changed, we load a separate sprite for each of these nodes from the player or from the skeleton scene there. And so these are all these different directories have to be defined for the clothes, and all the others, they just have one directory for each. But here the next directory will contain the actual customizable images. So you can see that we have all these different clothes that we can use, and this will be the key. Here will be the name, or the file name rather. So this will be like tuxedo.png, and there will be a tuxedo.png in all of these directories containing the image for the relevant node there, and we use this tr function here. So the names of these different customizable sets. So this lab code will be called lab code in the game, and this tr function lets us to translate this. So once the game is finished and we translate it to different languages, these customizable parts will be basically named in the player's selected language. And this is same for all these other customizable parts. So we will define all the available files and their appearing names in the game. We also have this custom color files dictionary, which will tell us that the skin color and hair color and facial hair color maps, which are actually just, they are like image files that contain these gradients. And this, we have the custom colors dictionary that will be loading, will be used to store these color maps in code. And then we have this like constant 500. This is just basically helps us normalize. So whatever the size of these color maps are, the game will not really care about the real size of the color map. We will just store it in a 0 to 499. Basically the XY coordinates from 0 to 499. Okay, so this, because this is an autoload script, this function, the ready function, will be loaded once the game is loaded, and they will basically first just go through these 3 color maps. These are the file names, of course, and we'll load those files, and we'll just add them to this custom colors dictionary. So this is very basic stuff. We just load all these 3 files, these 3 image files into memory, so we can easily access, like, basically based on the XY coordinates, which is the color that we should be looking at. And we will be loading the customization that is stored in this customization path. So basically the user's saved data, and if this returns an empty dictionary, then we will just use the random appearance function to create a randomized appearance. So if you start the game first, there will be a random character appearing for you. This is basically because we don't want that everyone who just starts the game and doesn't bother customizing their character to have the same character. This is for that. And we will use this setColor function. This will basically just extract the color information from the color maps. Let's just jump to this setColors. Yeah, it just takes a look at the X and Y coordinates of the color maps, and we'll use these image files to just get the R, G, and B colors. So this basically, why we do this is because in this way, when someone maybe they want an illegal color, so a color for a skin that is not on the color map, they could just go into the save file and just give their preferred RGB values, but we don't want that. We want everyone have to be forced to select their colors from our predefined set. And so basically that's why we use this color map that will be translated into an RGB variable. Okay, so I guess I talked about it quite long. So let's, and it will connect to this state change priority signal from the game manager too. So and this will be on game state changed priority function, excuse me, this is a very long function name, but what it will be doing is once the priority of this state change is 5, we will actually just check what is the game state. So if it is the lobby, then customization is true, and otherwise if the game state is start, so we are at the menu, this customization change is true, and if any other state that is not the lobby and not the menu, customization change will be set to false. What is this doing is basically you are not allowed to change your customizations in game. So that's what I was showing in the first and then it will enable my appearance and send customization to server if we are in the lobby. So because if you are in the lobby and you change your character appearance, you want everyone else to see your modified character at that point. And so the enable my appearance function, let's just jump there, that will basically set the appearance of the player, which is the current player, with the my customization. This set player appearance is just the function that will get a customization data, which is a dictionary, and basically just stores it in the customization dictionary. So this customization dictionary is a dictionary of customization data, and basically if it's me, so it's enable my appearance, then we use my ID, so the current player's ID, and save it to this customization dict, and it will emit the signal to apply appearance. And not surprisingly, this signal will be captured by the skeleton. So I could go there and show how it works, but first I want to clear up. So let's just accept it for the moment that this will basically tell all the skeleton scenes, which, remember, the skeleton scenes are inside the player scenes, and the player scenes are basically on the map, walking around the map, so they are the avatars of the different players moving around. And let's just accept that this signal, when emitted, will cause the actual appearance of the characters on screen to be changed. Okay, so let's go back where we were. We were here, send customization to server. So this is going to be the most important thing, I guess. So because we have to send the customizations to the server, which will distribute our customizations to the other players. So this one, send customization to server, is just does a remote a remote process call, I guess. I thought it's remote function call, but it's RPC, so it should be remote process call, I guess. Number one is always the server, and this will call the receive customization from client function on the server, which is here, and it will just use the customization dict with the network get my ID. So you might be wondering what's going on here. So I thought that my customization is always stored in this other dictionary. So that is actually stored here in the my customization. But, so this is the trick here. This is a big trick here, is when I change my customization in the editor screen, the parts on the appearance editor screen, that will be stored in the my customization directory. But if I cannot change my appearance in game, so we are not in the lobby, we are actually playing the game, this will be only stored here. But the game uses this customization dictionary to decide how the characters on the screen walking around will look like. So if my customization from here is not copied to this one, then that means that my previous customization, so the original, how I looked when I started the game, that will be still in this dictionary. And so if for some reason I need to send that out, then I will have to send to the server how I actually look, not what I selected, because I'm still looking on the screen my original appearance, and I want the other players to see my original appearance because I'm not allowed to change it, of course. So this will send this data to the server by calling this remote function, and so this function has been called and receives this customization data, and this one will also check who sent me the data. the server will also check whether it can change. So if we are in game, this customization change will be of course false, and in that case it will just not do anything. But if we are allowed to change the character, then we will basically broadcast this data. Well, what will happen here is that if the customization change is disabled, so we are not allowed, but for some reason we did not yet have this player's customization, then it will also let the server to broadcast the data. First, of course, it will set the player appearance for this customization, which is what we just looked at. So this will basically update the look of the player on the screen of the server. So of course the server is also a player. So this is the player who created the game. And then it will just use the RPC to everyone to send out who's. So this is receive customization from server with the ID and the customization data. So everyone else, every other player will also receive this customization data. And you can see this is this function. This just checks whether the RPC is coming from the server or not. And if also it will check whether it is my ID. So if the server tells me to change my appearance, I will ignore that. And then I will, the players will also change the appearance. So there is one more important thing regarding to the distribution of the customization data in this autoload script, and that is sending bulk customizations and receiving the bulk customizations. So the server can send all the customization data to a new player. So there are, 6 players already in the lobby, and they already have their own custom looks, and the new player who enters will need to get this information, and the server can just use this send bulk customization, and using this ID, it will just send this to that one player, all the customization data from its own customization dictionary, and the player will just basically check if it's arriving from the server and go through all the keys in this received customization dictionary and just add it to their own using this set player appearance. So the set player appearance, of course, will save the data in the customization dictionary of the player and then emit a signal to change the appearance. And I think this is like the most important part for the backend. So this is kind of the backend for handling the customization data. So if you make your own game, I think it is kind of, you have to, apply it to your own case, but I think this kind of backend makes sense. So it lets you to store all the customization data in one place. This is an auto-load script. So whatever is the game status, this script can be accessed, and this will persistently store your own data and also the other player's data. And they will provide you a way to sync this data throughout the different players, I guess. So another thing is the appearance editor. Let's just go back to our regular view here. So the appearance editor is basically kind of bland. Here we just fill it with a lot of this margin container and this H boxes and the V boxes. And basically this customization V box gets all the other things added here. So I built this, well, it's not my work originally, so this is coming from another contributor, but I worked on this quite a while, so hopefully I can explain it well, how it works. So let me press this button here. So when this is loaded, this is ready, it will basically create a the color selectors and the customizable body parts to put in the part selector UI element. So the things that you've seen in the beginning of the video, and I guess let's take a look at this again. So how can I... Yeah, okay, I guess. So this is how it should look like once everything has been added here. So you can see that the color selectors have been put in the top left here, and the bottom left here contains all the selectors. So if I go back to my thing here, if I can, let me just stop the execution here and let's hide this. So let's take a look. What does it contain? So it contains all these variables that are basically just the different nodes that you can see on the appearance editor for easier access here. So these are the nodes for the appearance editor and for the player preview. And we also have a few dictionaries here for the translation feature. So we want all these clothes, body, facial IDs to be translatable. And what else? We have a player sprite names. So while in the appearance manager, we had these dictionaries containing the file names for each of those, here we will have, like, these are the names of the nodes. So if I go back to the appearance editor and show you, so we will have all these things in this skeleton here, and so I want to be able to access those easily. So that's why we have the name of the nodes just stored simply in this dictionary. And what else? So there will be the part selectors and the current selections also stored in dictionaries, and it will contain the currently selected customization. Because, so this one, we need to store it separately from the appearance manager, because while we are changing these things on the screen, and before we press the save button, we don't want this to be stored there for obvious reasons. So if the player presses cancel, we want to just continue using the original customization, not the new one. This one also contains the shaders, because we need to... why is it called shaders? Anyways, this is like the name of these files that contain the color gradients we can use for color selection, and these are also just for the translation purpose here. We will have the color selectors that will contain the color selector boxes as a dictionary, and this is the same as the part selectors. So basically the UI elements, the instanced UI elements, are stored in these dictionaries themselves. And how does that work? So let me just go back to the 2D view. So we have these color selectors and part selectors separately, and those are put inside, or those are instanced on the screen. So you can see them put on the screen as I just showed you before, and those instanced ones are going to be stored in these dictionaries, as you can see here. So in the ready function, we are going to be creating the customizable color palettes here. So we just go through this color selector dictionary, which contains all the 3 color selectors we want to use, and we will instance them, and you can take a look at the code here, which we will set up the label for the color selector. So the color selector looks like this. It has a label in the top left corner, so we can change that to whatever name we want, and then we will use this color map to be loaded there and give a name to it, and then connect it to the color changed event, I guess the signal, and then add this as a child to this customization VBox, which is right here on the left. So the VBox will take care of the layout of the screen for us there, and the same thing will happen for this player part selectors. So we will instance them based on these dictionaries, and then just like here, the color selector is put in the color selector dictionary, the instanced one. The part selector is also put in this part selector dictionary. It's a little more complicated than the color selector because we also want to add all the available part sprites to this list. So the part selector will know, each part selector will know. So for example, the body selector will know all the body types, or the clothes selector will know all the available clothes. So we have to add them so we can, all these will be able to cycle through the available elements there. Alright, so this is the important part for the already function. We have to take a look at these signals that are connected here, the onChooseColor and the onPartChanged. So these will be whenever a color is selected from one of these color selectors, that will trigger the color changed signal. If we want to take a look at this, so it has this color change signal, and whenever we set a color, it will basically emit this signal that the color has been changed. So this is kind of, I don't want to go through this code exactly how it works because it's a little more complicated, but basically what it does is just it follows the mouse pointer when it's clicked. So you need to check this, like the input of a mouse button. If you want more details, you can of course always look up the code for the color selector.gd on our GitHub repository. This is just a high-level overview I'm giving you, so don't expect me to go through every line of the code there, but anyways, so there is also an emit signal in the set current part, so it's a little more easier because it just has two buttons, and if those buttons are clicked on, then the next item in the list is selected, or the previous item is selected depending on which button you have clicked on, and then both of them will trigger the part changed signal, and these are all connected here. So on choose color, we will basically just the new color is emitted with the signal, so we just add it to our, or rather modify the current customization with that new color and update the preview, and the same thing will happen when the part is changed. Just this part selection is, we have like a kind of a checking mechanism as whether it's like valid thing that have been selected, and then this customization will be added and the preview will be updated. And that's update preview. What does it do? It's a little inefficient because it doesn't really check what have been changed. It will just go through all the three color palettes and will apply the colors to the material, to the shader on this player, or this player skeleton there. And this shader, I already made a video describing how this shader works, so you can take a look at that. And it will just go through all the parts in this sprite nodes and just basically gets the file paths from the appearance manager, because it needs to load the files, and it will need the load. It will load the files there and just change each texture to this file. And yeah, so this is actually quite inefficient because all the sprites are loaded no matter what have been changed, because this update preview, it doesn't accept any arguments. So we could make like another update preview, or we could, instead of just doing the update preview, we could basically just do the modification, the relevant modification on in these functions that are called when the signal is emitted. Alright, so we're almost done. We're almost done with this. So we talked about the backend, and we talked about like the backend which is responsible for storing the customization data, and we talked about the customization interface itself, and the only thing that's left is the player. So how are we handling this? So if I go to my skeleton here, what is the code in my skeleton? And my skeleton has this apply customization function. It's very simple. It receives this customization data, which is a dictionary, and it will go through the shaders and then applies these things that are stored in this dictionary for the colors there. And this is basically does exactly the same thing here that our appearance editor would do on the sorry for scrolling too much. Where is this? The update preview. So the update preview, it works in the customization screen. It is separate. Then we are not using this apply customization there because this one just applies the customization to the skeleton in game from this. Probably kind of guessing that because we use the same skeleton as part of the appearance editor, we could probably just use this, especially because we don't do anything efficient here. So this one, of course, because this case during the game itself, when a player changes their customization, everything has been changed, or rather anything can be changed. So they just send their new customization data there. So it is, of course, we change everything. So it is not that easy to be efficient here. We could make this appearance editor more efficient, I guess, if we really wanted to. And this is all this skeleton does. But why does it do the apply customization? So that's in the player. And so actually, this apply customization function is called from the player.gd, which is for the player script. So remember that the our player has the skeleton as its child node. And so there is some kind of issue, or not issue, it's kind of a design choice that this skeleton node gets reparented sometimes, and so how I solved it, because I don't really understand when and where that happens, to be honest. I just check whether this skeleton node exists where in this sprites viewport, or does it exist just as a skeleton node, and whether it doesn't matter how it exists, it will just use the apply customization function. So it will call this apply customization function for the skeleton, and before that it will just get the data from the appearance manager. So this function is only called with the customize ID. So what is the character what is the ID of the player whose character should be customized, and if it's not the same ID as the current player instance, so this ID variable here, if I go back to the very beginning, it is declared here, and this is the unique ID for this player instance. So this will correspond to the ID of the player. So the player instance has the same ID as the ID of the player whose instance this is. I hope it's easy to understand. Well, anyways, so how is this function get called? How is the customize player function get called? That's the other thing we have to check. And so one of the times when it's called, it's just directly in the ready function. So when this the player scene is instanced in the map, or on the map rather, or in the map, I don't know. But anyways, then it will be the customized player function will be called with its own ID. So it will be doing that but it will also connect to the appearance manager's apply appearance signal. So if we go back to our appearance manager here, this one has, let me just slowly scroll down there, it has a signal somewhere. Where is the signal? Yeah, okay, I'm just blind. But this is the signal. So this appearance manager has this apply appearance signal, and this signal is emitted whenever the appearance of someone has been changed. So this enable appearance and set player appearance, these are both emitting these signals with the ID of the player that has been changed. And as we have to keep in mind that this one is all of the players. So all the players have been instanced. So when we instance like 8 players, so 8 players are playing the game, we instance these 8 player scenes on the map. I guess it's on the map, not in the map. But anyways, so we instance these 8 players, and everyone is connected to the appearance manager's apply appearance signal. So that's why we have to check the ID here. So when this apply appearance signal is activated, then it will send out the ID of the player who changed their appearance, and basically that only that player instance, every other player instance will just ignore, it will just return and ignore everything else, and the ones that have the same ID, that will be applying the appearance to themselves. Alright, I think this video can end now. We don't need to take a look at this code anymore. I think I gave kind of a detailed description of how things work, but this is definitely not a tutorial in the strictest sense, but I think it gave you some idea of how this character customization system works in OpenSuspect, and maybe you can apply it to your own project. If you have any other questions for this kind of video, or if you want some other part of our game to be explained by me, then you can, ask these questions and give those suggestions down below. If you enjoyed the video, don't forget to like and subscribe for more content, more free software programming and OpenSuspect and Linux, Arch Linux related content is going to be coming to this channel. I'm not promising you any schedules because, well, videos are coming whenever I have time to record and edit one. But anyway, subscribe if you don't want to miss the next one, and I will see you in that. Bye bye.